Hi, everyone. I think we can get started. My name is Scott Shaw. I'm the head of technology for Thoughtworks here in Australia, and I'm going to be the MC for the talk today. Our speaker is going to be Heiko Gerin. I think Heiko is somebody that I've known for a while, both before he joined Thoughtworks and since we work closely together. I think he's uniquely suited to talk about this topic about developer effectiveness or engineering effectiveness. He's seen this from several different sides as a manager, as somebody who's responsible for operations and maintaining applications in production, and as somebody who's been helping delivery teams deliver in very large scale applications most recently. So I hope you will enjoy the talk today. I'm sure it's going to be some interesting findings in there. I do want to tell you at the end, we're going to post a link to a feedback form that we would love for you to fill out. We always like to know what people are interested in, how these talks are being received, and what sorts of topics we should be covering in the future. So with that, if you want to, I should probably mention to put your questions in the Q&A, and I'll try and keep an eye on that. And we will have time for questions at the end. Okay, with that, I'll hand it over to Heiko.
Thank you, Scott. I appreciate it. Hello, everyone. It is a bit strange. It's the first time I'm doing this, so it's a bit disconcerting to just talk at a laptop, but I'm sure I'll cope. I've got Scott looking at me and see how he reacts, and he can proxy the audience reactions in chat. So I'm Heiko. Thanks for the introduction, Scott. I've been with Thoughtworks for about 3.5 years now as a principal consultant. But yeah, as Scott said, I've sort of been around Thoughtworks for over 10 as a client in many different places. So the last 3.5 years, I've been a principal consultant, and I've done a lot of delivery work with like small and large clients in Australia. But about 2 months ago, I got asked if I would like to take on the role as head of engineering for Thoughtworks Australia. That is quite an interesting position to be in. So I suddenly found myself going from being in charge of like a single account, like maybe 5 to 6 teams, and making sure that they deliver to all the commitments we make to our clients, to a larger number of teams, about 63 projects in flight with Thoughtworks Australia currently. And they span the whole gamut of like life cycles of projects that they would be in, operational projects, infrastructure project, classical software delivery projects, and basically every single tech stack that you could shake a stick at. So we've got a lot of variety out there across industries, sizes, and customers as well. And we're also doing a decent chunk of distributed delivery with China and India Thoughtworks teams. So given all of that, I've been thinking about how do we know we've been successful as software engineers and as software engineering teams? How do we measure it, and how do we make sure that our clients are happy with the work we're doing, whether that's the clients of our consulting, of our consultants directly, or their clients delivering products and services to them. Now, what we're going to talk about today is basically a distillation of that. So engineering effectiveness, I'll give you the definition a little bit later on, but it is just in a nutshell, like delivering software better or delivering digital products and services better. But how we're doing that is via teams that are actually happy doing it and are high performing. There's also something about like measuring and knowing how we've been successful, how and when we've been successful. And there's a little bit about developer portals. Developers portals have been in the media a fair chunk in the last couple of years, superseding a bunch of other tools that used to be the go-to for being better at software delivery, but we'll talk about all of that. We'll start with this and a quick definition of what engineering effectiveness is. And it's a bit of a simplistic graph. I've basically always wanted to put something into a public forum that has axes labeled as with time and money. So I apologize for that, but imagine any engineering organization or any product organization in general. Ideally, they'll scale up and have their revenue grow over time. I guess that's not always the case, but let's assume that that's the case in this case. They will then almost as a linear factor of that spend effort and money on delivering those products and services. Like I've labeled this technology spend, but what we're after though is what sometimes people refer to as economies of scale. So just being better and more efficient at what we do when we deliver goods and services to our customers. So represented in this graph, engineering effectiveness is this green little area here, which is if we manage to be better at delivering goods and services, we'll be able to do it cheaper and we'll be able to make more money in the long run. This has been given many names in the past. Some people call it developer efficacy. I didn't name the talk that because I can't really pronounce that well, but sometimes people call it developer productivity or team efficiency. I sometimes call it just being better at software engineering or being better at delivering products and services. Traditionally, so this graph has been around in many different forms, many different shapes, in many different forums. But traditionally, it's all about cost compression. Like, how do we make sure that we squeeze our engineering or our delivery teams into being just a little bit better, just being a little bit more cost effective? How do we make sure that we make the best use and exploit our resources as best as we possibly can? Now, how do we make sure that we deliver at the most effective level that we possibly can? The first thing we need to talk about is false trade-offs. And here is one that's fairly well known. It's by Martin Fowler, it's the chief scientist at Thoughtworks. And he's saying that in software, the intuitive trade-off between quality and cost does not apply, and that high quality software is actually cheaper to produce. Now, that is something that is not inherently obvious, and it's definitely not intuitive. When you think about, say, consumer goods, there's always in our minds this trade-off between buying a more high-end device that is of better quality versus a low-end device that might not be as good quality. Now, in software engineering, this is a false trade-off. It does not really apply. And that's because internal quality, the things that people won't see necessarily, the way that software is structured, the way that the modules are working together, it's properly tested and changeable. All these things factor in being able to deliver changes to customers. So ultimately, delivering better quality, better internal quality software means that we're able to serve our customers better. That's what Martin talks about when he talks about it being cheaper to produce. So here's another false trade-off that's really relevant when we're talking about engineering efficiency, and that is velocity and quality. So many people think about these two things as things that need to be traded off against each other, so that going faster and going in high quality are mutually exclusive. So you need to do one of them at the expense of the other. Now, that is also a false trade-off. That is not true. So there's been rigorous research in the last couple of years by the DevOps Research Institute that says that these two things are not to be traded off against each other. Instead, they're mutually supportive. So organizations that go at higher velocity also go at higher quality, and the other way around. It's summarized in the book and a bunch of research in the State of DevOps reports in the last couple of years. These four things on the left-hand side is what they call the 4 key metrics. 2 of them are related to velocity, like how fast we deliver software, and 2 of them are related to quality. So how stable the software is in production and how quickly we can recover from it failing. Now, these 4 things are actually predictive of organizational performance. So organizations that perform high in these 4 key metrics are twice as likely to meet or exceed their goals. And when we talk about goals, that is both commercial and non-commercial. Like that's at its most boring, maximizing shareholder value, but it's also getting a high satisfaction rating in their products. So there's actual rigorous body of research behind all of this, and it is quite interesting to know. And what that means also is that suddenly it's not about cost compression anymore. Suddenly it gets a lot more interesting, because if we manage to go both faster and at high quality, then we can deliver software better, keep teams more engaged, while at the same time also compressing cost and being more efficient. Like it's basically the best position to possibly be in. And that's really interesting for people and for engineering organizations. So what do we do? So obviously we want to make engineering teams go faster and be more effective at things and improve stability at the same time. So what do? We go and get ourselves a tool. We go buy one. there's a lot out there at the moment. Developer portals promise a lot of things. So they promise to make developers go faster, onboard them quicker. They promise that the developers can just go and like combine all these things that already exist in the ecosystem together and like rapidly iterate and create new products. And the onboarding time decreases. People ramp up incredibly quickly, and people can just discover everything in the ecosystem. There's a surprising number of tools out there at the moment that promise to do that. I've listed some on the right-hand side here. Interestingly, there's even Drupal in there that's delivering a developer portal. Now, there's something about that though, and just buying a tool and might not be the right answer. Because you could just easily go and substitute the word developer portal out of all these promises and replace it with middleware or enterprise service buses or, I don't know, Oracle service bus, low-code platforms, no-code platforms. All these things have been promising us for decades that they will be able to make us go faster. And for most of the time, they have not managed to do that. So tools are great, but what doesn't need to be true to make the best use out of them? And as an extension, the question is, how do we build high-performing, happy engineering teams? And I'm going to talk a little bit more about that in this next section. I've divided it into 5 tips of how to do that. And first one is build more effective teams. Second is reduce coupling. The third, applying the right level of governance. Improving delivery and engineering practices. And the fifth, keeping teams happy and engaged. Start with this, building more effective teams. We'll start with team size and setup first. What we've learned as consultants and what we've learned delivering software, or I've learned delivering software, is it shouldn't be about individuals, but it should be about teams. So make teams the fundamental unit of operation. Don't necessarily focus on individuals so much, but on teams. I'll talk about what the bit about aligning to the flow of change is a little bit later. The teams should be long-lived and stable. And the goals that these teams have should be team goals, not individual goals. That helps with the avoidance of fragmentation. Fragmentation meaning that large teams sometimes break off into smaller groups of 1 or 2 people that have sometimes conflicting, sometimes adjacent goals to the rest of the teams. And the last bit is the team size. There's a decent amount of research out there of cognitive scientists. There's one here called Robin Dunbar, and he's found that there's a certain limit of groups of people that you can trust, or that you can keep, the number of relationships that you can keep in your head at the same time. So they're called Dunbar's numbers, and we found it quite useful to organize team constructs around those Dunbar's numbers. So 150 is the maximum number of relationships that a person can maintain in their head. When I say that, I mean like the maximum number of people that people know what they're doing and they can interact with reasonably. So that's sort of when we talk about department size, that is normally where we use that number as a maximum. And then there's these 2 numbers between 5 and 15. That's the highly trusted circle, with like 5 people being immediate family and 15 people being like trusted groups of friends. Delivering software between 5 to 9 people seems to be a good sweet spot of what we do find to be successful. And most frameworks out there tend to agree with us. Like versions of Scrum or XP, or even operating models that are inspired by Spotify or by Amazon, they all sort of have team sizes of about that. And we found that quite useful too. The second thing is managing cognitive load. Cognitive load is something that is not necessarily talked about much, but in its essence is the cognitive load is the total amount of mental effort being used in the working memory. That's a psychologist's research speaking there. But colloquially, it is basically how many things do we can reasonably be expected to be working on at the same time before we get overwhelmed and we start to be fragmented and we start to get really stressed. And in software, that is quite interesting because like software systems only ever keep increasing in complexity. And it's quite common for teams to start out, be really high performing. Again, 5 to 9 people, they have a maximum cognitive load. And after that cognitive load gets exceeded, they stop being as productive as they could be. So in some cases, teams that are incredibly effective and efficient at first and really high performing, as they are almost a victim of their own success. They start to accumulate more things that they've built, more things they've put into production they now need to maintain. And they stop being effective because their cognitive load gets exceeded. Here's something that we've done at a client recently to give a bit of an idea of what's the effects of that could be, fragmentation. So in this particular case, the teams at that client were of about the right size. We were like 6 to 9 people, but because of the massive cognitive loads, there were smaller teams that formed, smaller groupings that worked on single things, like 1 or 2 people, with one of them being the team lead or feature lead. And we did an exercise capturing all the rituals, all the types of work people do, meetings, like doing customer support because it was a DevOps style organization, ceremonies, like actually like leading features. And we did the math on what all that did to like the ability of that team to do planned work versus, tasks and like random stuff that happens as part of production support and overhead. And if it's a team of 2, the capacity for or the ability to do planned work is actually just at 50% of that team. If you go up to a larger size of say like 6 people, it becomes more reasonable, 70%. So how do we manage cognitive load? So we talked about before that an ideal team size is 5 to 9 people, and that there's an upper limit to that team's cognitive load, limited by the amount of people on it. The book Team Topologies gives us a pretty good idea of what you could do. And it's a concept borrowed from domain-driven design. It's the idea that you have to go and identify domains, like domains of things that a team needs to do. Like in a wide sense, that could be, say, marketing as a department, or like an activity, something like that. In a more technical sense, it could be, say, continuous integration, or it could be cloud platforms. So the idea is that you go and identify those domains, and you classify them into different types. 3 types they suggest, like simple, complicated, and complex domains. Simple being a change to a domain like that is really trivial and takes a person maybe one iteration. A complicated one taking a larger team more than one iteration, 1 or 2 times the time and to get it right. And a complex domain is something that is inherently difficult to grasp. And then they say, like, after you've gone and identified those domains, and you've done a little bit of calibration between different teams, different domains, just to get it about right, you apply some heuristics, and they're here on the right. And it's quite refreshing to see that as a consultant, because sometimes we find ourselves in a position where we get asked, oh, so how much work do we need to give a team? And we always say, oh, right, depends. The authors of this book are not doing that. They're basically just saying, no, it's that, do this. No more than that. And that's quite good to just have as a bottom line. It's not always the truth, but it's good. So the heuristics are that you should assign a single domain to a single team. If the domain is too large for a single team to handle, go split the domain. Don't put more teams on it, but keep the ownership of one domain with one team. You shouldn't be giving more than 2 or 3 simple domains to a single team. And if a team is assigned a complex domain, they shouldn't be getting any additional domains assigned at all, even if they're simple ones. And lastly, you want to avoid having a single team be responsible for 2 complicated domains. It's quite simple when you start applying it to domains that you've identified, but these are really good rules of thumb to structure your team and workload by. There's something to be said about diversity of teams, and diversity is something that's been talked about a lot in the industry. And I'm just going to mention a couple of things that came out of research, and that is that if you've got more diverse teams, and that is diversity in terms of like race and gender and background, they focus more on facts. So diverse teams are more likely to constantly re-examine facts and remain objective. They also process information more carefully and outperform homogeneous groups in like decision making. And at last, like businesses that are run by cultural diverse leadership teams are more likely to develop new products than other teams that are more homogeneous, which is quite interesting. There's one more thing that is not talked about too much, and that is role diversity. And we found it incredibly useful to foster a culture of what we call maybe polyglot engineers or polyglot people in teams, people that have the ability to pick up more than one task and role as they go. It's the opposite of like extreme specialization into, say, like front-end engineers, back-end engineers, full-stack engineers, or different types of UI specialists. Now, all of these specializations do have a point, and there is a good reason to do it in some cases, but we found that in most cases it is better to foster people that are more broad in their skill set, because it also like helps with the diversity of thinking. And it's also a lot better than engineers doing everything, which sometimes happens in engineering-led organizations, because they would then just do everything just a little bit worse than what people that specialize in those tasks could do. So this is just to make another point about skills and polyglot skill sets. So we think about it, and this is a model that Ken Beck came up with in terms of, we call them paint grip people. So like imagine that there's a paintbrush that's applying skills being dragged along a canvas multiple times over and over again as we get put onto more projects, as we do more work. Sometimes a drip of paint forms, and that's sort of a specialization, a skill set. And imagine that the red drip there is infrastructure specialization for developers, for example. Sometimes the drips form as we gain more experience. Sometimes they roll down, become longer. Sometimes they don't. So that's a good way to think about polyglot engineers and the type of person that we think is best working in a team delivering software or delivering products and services in general. Tip 2 is all about reducing coupling. And to talk about coupling, of course, we're going to talk about Conway's law, and that is something that got coined by a computer scientist called Melvin Conway, saying that any type of software system or any type of distributed or complex system will ultimately reflect in architecture the team structure that built that thing. So that means that organizations that are arranged around like functional silos, like a QA department, a DBA department, a security department, they're unlikely to ever produce a software system that is like designed for end-to-end flow. It also means that organizations that are arranged around, let's say, sales channels for different geographies, they're unlikely to produce a product that would work in every single geography, if that makes sense. So the main point being that software architecture and team interactions are similar forces. So we talk about a couple of types of coupling and what their impact is, and then we'll move on to what you can do about them. So coupling, at its core, like increases friction, context switching, introduces delays and wait times, and handoffs when making changes. So it just makes things a little harder, and it can be quite confronting when you've never seen what the actual impact is. This one you've probably seen before, architectural coupling. It's a common occurrence in software systems where there's individual teams that own, say, like the front end of an application, and there's different team with the back end, and they all have to interact with, say, a core database team or a core operations team. So getting things done for these teams, if they need to make a change in, say, the core database and need help of the operations team, will always introduce frictions and wait times. Here's one that it might not be as obvious, and that is called backlog coupling. So imagine a delivery team that needs to ship a change into a production environment, and they need to get approvals. There's a change advisory board. They need to get the database team to do something for them. They need to get an external team to do their load test for them, and they need to raise a ticket because somebody needs to provision them infrastructure. Now, a couple of Thoughtworkers some years back did an experiment with a large Australian client, just measuring how much doing that, how much having an external dependency has an impact on the speed of delivery. And for each team that there is a direct dependency of a delivery team on, the task execution time gets 12 times slower per dependency. So you can imagine if you've got a delivery team that needs to wait for like 5 or 6 teams to do something for them, how that adds up, because it's like 12 times times 12 times times 12 times. That's quite staggering what the impact of that can be. Here's one that's also not talked about much, and that's delivery and temporal coupling. So I'm talking about coordinating releasing software, releasing products across multiple teams. So sometimes there's this concept of a release train where many teams bundle up their changes together, and there's a predetermined window where all of these changes at the same time get shipped into production. I've drawn a little picture here of a simplistic view of a client that I've worked with in the last couple of years. A team, let's call it Robbie, named after fictional robot, needs to make a change in a monolithic code base that is on a release train, and 2 other teams need to get onto that same release train and ship a change, but they also need to make a change in another component. We've taken the change failure probability of a single change out of like some ITSM systems, and 7.5% is on average how many what the probability of a change failing is. Now, all these teams are now coupled together, and if one of them introduces a breaking change, it will also mean that the changes of all these other teams fail. So the impact of that is quite staggering, because you can apply the magic of math, and this is the actual probability of a change failing of a single team. It's 26.8%. And this is a small type of setup. I was working with a client a year or two ago that had a situation where they had 3 teams that needed to make changes in 2 different monoliths, and their change failure probability was sitting at 36%. And the interesting thing is you can then calculate what that would mean in terms of additional cycle time for a change. So for 36%, their additional cycle time was about, say, 9 days per change. But the way that senior management in that organization decided to fix the problem is to just add 3 more teams, because adding more teams will always make you go faster. We did the same exercise then, and like with 3 more teams added, the change failure probability went up to 50.7%, and the maximum additional cycle time per change went up to 29 days, so almost a month per change longer. So at that point, it is most definitely not worth it adding more people to try to make the boat go faster. Overall, release trains are a technique that should be approached with a good degree of caution, if at all, in summary. So what can you do to reduce coupling? There's a couple of rules to live by. One is that single ownership principle, like a single team should be responsible for a single piece of software. Ideally, being able to make a change, maintain the thing in production, get customer feedback. That's what we mean by you build it, you run it. The third bit is about making use of internal platforms. Internal platforms, there's been a lot of talk about that, but reducing cognitive load for teams, abstracting away things like infrastructure provisioning, where appropriate, of course, because we sometimes see platforms in very, very small organizations, like teams that have organizations that have 2 or 3 teams that think they need to introduce a platform team. That is probably not the best use of their time at that point. And the last one is aligning teams to value streams. Again, going to the single responsibility principle, you want to have a single group of people, a single team, be in a position where they have a direct impact on their customers. So the thinking is to align along single products or services or a set of features, and you can do business domains, or you can do feature groups, or like differentiate via geography. Say there's a team that's just responsible for serving the Australian market. Sometimes by criticality makes sense as well. The more business critical applications grouped together and owned by a single team. But most commonly, and what we find to be the most useful, is along customer journeys. Imagine you're at a bank, like one customer journey would be, I want to like request my balance, for example. You could have an entire team that's arranged along those lines. What you can also do is what's sometimes referred to as the inverse Conway maneuver. And if you've ever read up on microservices, that's something that comes up a lot. It is the idea that you organize you set up your teams and you organize the way that they are structured in a way that you want to resemble good architectural dimensions. So ideally, you just like do the dreaded reorg, and you have a single team assigned for all tiers that are necessary in delivering this customer outcome, clients or APIs and data stores all together. And that has a couple of really good side effects, like the things on the right: loose coupling, high cohesion, and a clear, appropriate version compatibility between things. And something else you can do, and this is also again taken from the team topologies, and that's to standardize the way you think about teams and introduce a couple of standard basic team constructs and keep that language consistent. And their core vehicle is the stream aligned team. So when I talked before about aligning along value streams, that's what that means. Ideally, you want about 70% of the teams that you have to be value stream aligned. And those teams should be augmented by all these other 3 team types. So platform teams providing the ability for stream-aligned teams to go faster, enabling teams sometimes being referred to as coaches, but that can also be, say, a security department that shows stream-aligned teams on how to comply with security by doing it together with them. And there's a subtype that is called complicated subsystem team. That could be a very specialized domain, say like a high-frequency trading team, or a team that maintains a set of very, very specialized machine learning algorithms, for example. But the core idea being is that you should be focused on stream-aligned teams first and foremost. And for platform teams, that is a fractal thing also, because you want to have your platform features also aligned to streams. So you can, it's basically like stream-aligned teams all the way down. Tip 3 is applying the right level of governance to teams. What we've found to be the most successful is to aim for highly aligned, loosely coupled teams. So that allows them to move at the highest possible speed while maintaining the highest amount of stability. We called it steer the ship, but avoid the rocks. But in essence, like having the right level of governance and allowing teams to go just as fast as is possible without putting the organization at risk is actually a huge competitive advantage. Not because many places and many organizations think of governance and controls as something that needs to necessarily slow things down. As we've learned in the very beginning of this talk, this is not the case. This is a false trade-off. We need to be able to maximize throughputs, and we need to be able to maximize stability at the same time. There's a couple of ideas on how to do that, like moving from mandates to visions and principles and putting guardrails in place for teams, embracing sensible default practices, which is just a set of engineering practices that you think are most of the time the right thing to do, and people will just need to have a good reason to not do them. There's one about enlisting gatekeepers as collaborators. That's why the enabling team makes a return in this slide. Is take a security team, for example. You don't want them to be the keepers of the kingdom to production. The same with like traditional operation teams. You want them to be there, collaborate with the team, show them how to meet compliance goals by doing it together with them. And the last one is providing paved roads, which is why the platform team is back here again as well. You ideally will want to reduce cognitive load for teams as much as you can. With one caveat though, if you think back about the stream-aligned ratio, like you want to have at least 70% of your teams actually delivering customer value. So if you've got 2 teams, making one of them a platform team is probably not the right ratio. If you've got 10 teams, absolutely, that's probably worthwhile. Tip 4 is improving engineering and delivery practices. Now, this section is going to be a little bit shorter than you might expect, because in essence, like at the end of the day, all the teams that you have, they need to invest in proven practices and techniques. Like to make all these things useful, to make use of a loosely coupled team, to make use of a right amount of governance, teams need to be able to trust their delivery. And that goes back to that quote by Martin Fowler in the very beginning, in that we need to be able to ship quality software that has internal quality. We need to be able to change things quickly. We need to trust the things we're doing. We need to be able to test everything. We need to be able to experiment. We need to be able to get closer to our customers. And a number of those things on the right here, this is just ours, basically. These are the things that Thoughtworks as a whole, in over 20 years of delivering agile software, has started to believe to be true. Like these are things that we believe are a good place to start. And there's things in there that you probably wouldn't be surprised about, like test-driven development, pair programming, maybe a little bit more controversial, but in the end, this is just a means to an end, right? It's a means to achieve an outcome. There is one thing though that I want to call out specifically, and that is continuous integration, and by extension, continuous delivery. One thing that we find a lot recently is a push towards using pull requests, and pull requests as a vehicle or as a tool are not necessarily a problem, we think. Where it starts to get interesting is when pull requests become asynchronous, because this is a quote by Keith Morris, like using asynchronous pull requests for code changes by your own team members is like having your family members go through an airport security checkpoint to enter your home. It's a costly solution to a different problem. That's exactly what it is. So it's almost become the default in the industry to go towards a model that introduces pull requests for everything, Git flow, like massive amounts of feature branches for making changes to infrastructure environments, for example. Now, it's one of those things where I think the tool itself may be too heavy-handed in most cases. Because why would you go ahead and like build a very sophisticated continuous delivery pipeline, fully automated, with the ability to deploy infrastructure as code at the click of a button, but then go ahead and say, you know what this needs? A manual queue and a choke point with a single person that needs to review a change. It is fundamentally, we believe, in most cases, the wrong approach. Now, again, asynchronous pull requests. Pull requests itself are not the problem. It's about the way that they get used in most places, which is wait times, things sitting there, things batching up, and then massive changes, inviting people to just say, it looks good to me, and small changes being nitpicked into oblivion for like simple stylistic choices. Last tip is to keep your teams happy and engaged. And we talk about culture. Culture is it's a really hard thing to grasp. Generative culture is something that has come up in the DevOps research and in the Accelerate research as well. They refer to a construct by a psychology called Westrom in there. They call it generative culture. I'll talk about the contents of those on the next slide, but it's all the things we think are good about culture. So how do we get to a culture that is beneficial and people are actually enjoying their work, people are not burning out? And it is like getting teams closer to their customers, being able to get direct feedback for the software that they built. Something that I've mentioned before is setting team goals over individual goals, reducing cognitive load, we've talked about before, to minimize burnout. And the other thing is like, you want to be able to have teams be able to interact with people that represent their craft in other teams, like via communities of practice or guilds or other constructs like that. And finally, giving individuals the autonomy to make decisions that affect their work. So especially when they're directly accountable for the outcome. Here's something that is probably quite interesting for people that have done continuous delivery and like lean things before. This is again from Accelerate. They have proven using math and numbers that lean practices like visual management systems and limiting WIP and continuous delivery actually are statistically predictive of like a generative culture that has all these traits that we think are good and keep people engaged. And that generative culture has a direct impact on teams being able to deliver software better. So how do we know we've been successful? How do we measure effective engineering teams? It's all about giving teams the right signals. So if you think about the way that we want teams to interact with their environment, is you want to give teams the ability to see how what they're doing on a day-to-day basis has an impact on their customers. So ideally, you want to like show them what is going on and show them if they're operating outside of risk tolerance. Is it most important to like operate within budget at any given point in time? Or is it most important at any given point in time to satisfy their customers? Are teams operating outside of risk tolerance? They probably will adapt their behavior almost immediately based on that feedback. The second thing is to avoid single activity metrics. So things that just represent an activity taking place, like story points completed, or like lines of code that get changed, or number of code commits. You want to see that combined with other dimensions. I'll talk about those in a second. The third thing is don't overwhelm teams. Give them a handful of metrics that are meaningful. Don't give them a dashboard with 57 activity metrics of all the things that have happened. It will overwhelm them. And the last thing is be deliberate about what you're signaling, because teams will adapt their behavior based on what you incentivize them by. We've been in an organization where the most important thing for individual engineers was to be seen as a tech lead or a feature lead. And they get financially incentivized by starting new work. And with the end result being that there was a huge amount of work in progress and the cognitive load ever increasing in this organization. Here's one way to measure engineering effectiveness on a continuum, get created by Nicole Forsgren when she was at GitHub. Her idea is that it would be good to measure things on 3 different levels, at an individual level, on a team level, and on a system level, along a couple of different dimensions, like satisfaction and well-being being one of them. So how fulfilled and happy a person is, or a team is, or a system. Performance, like the outcome, we talked about that. Activity measures are still important, but again, in the context of other measures and other dimensions. How people talk and work together. And finally, how efficient is the system and how are people able to do their work and not being interrupted. I know it's a bit abstract, so I thought I'd give you an idea of how we do this at Thoughtworks at the moment. So we do individual satisfaction surveys, at least for the most part. And we also think about team temperature as a team measure for satisfaction, like a simple survey that asks, how happy are you, or how supported do you feel at this given point, from 1 to 10, basically, anonymous survey to give us an idea. We look at outcomes as well, specifically scope shipped. We do burn-up charts just to give us an idea of how is the team tracking from what they've promised their customer to what they've actually delivered. System ones are a bit harder. We try to do client satisfaction surveys and just ask our main stakeholders how happy they are with our work. But in the end, what's more important though is that the teams are actually delivering something useful to a customer, which can be harder to measure. In product companies, that might be a bit easier with CSAT scores or customer satisfaction scores. We also look at reliability. So you see the 4 key metrics from Accelerate making a reappearance here with deployment frequency and lead time for change, and the two reliability metrics. We do capture those quarterly, and we're aiming to up the frequency of that quite significantly. And we look a little bit at ramp up time, how long it takes for individual team members to become productive on a team. We bake that into our estimations, just to give you an idea of what we have known to work in most cases at Thoughtworks to tell us whether a team is effective and delivering good outcomes for the customers. And now we loop back to something we talked about earlier. How can tools actually help us? And while I was bagging a little bit on developer portals at the start and saying that they're just like enterprise service buses, that is actually doing them a massive disservice, because once you've done a lot of these things I talked about, and once you've actually set up your organization to be in a position to deliver effectively, something like a developer portal can be incredibly useful and can be an incredibly useful tool. Here's how we think about the things that they enable us to do. Discoverability and visibility, especially if you've got a larger state of software and a larger state of systems, just being able to find out what is there, what team has built what capabilities are there is incredibly useful. Delivery accelerators, that is basically getting started, like being able to push through a change into production using an established pattern, an established language within minutes. That is incredibly useful. Technical health reporting, it's all about aggregating service level objectives or reliability measures, just giving us an idea of how we're tracking in real time, using that as this signal for teams if they're operating within or outside of risk tolerance. And the last one is data aggregation across the hierarchy. The ability for us to map how domains and systems interact with each other and how they map to each other. So there was a number of tools I talked about earlier on that we've seen. We've evaluated a whole bunch of them. With what we've got the most experience is Backstage. Backstage.io is a product by Spotify. It does most of these things. It does domain system ecosystem modeling. It's a screenshot up there for what it looks like. It gives you the ability to just model complex interactions and hierarchies and how all these things hang together. We found it to be working quite well, but again, all these other tools do that to a varying degree as well. The software catalog idea is a great one as well. Just having an idea of what's available, what people can use. It comes with a templating engine. Again, most of these tools do. And it comes with a very fancy way of establishing technical documentation. And it's also very easy for developers to use. It's just as easy as installing or including a YAML file in the source control for a single project, initiating it, and then it, in most cases, goes away and does magic, and you can go find things. We've done a couple of projects with Backstage, and again, This is probably true for a number of other developer portals. And here's where we found them to help. Developer onboarding time is probably the biggest thing. Like being able to get 55% increase in developer onboarding time is huge. And that's something that Spotify has done with using that tool. And again, not just about the tool, but about a number of other things. Increases in deploy frequency. And it also helps with fragmentation. Now, just keep in mind, all these things, take them with a grain of salt. I say them because we do have a partnership between Thoughtworks and Backstage. So all these other things probably will do similar things for you. We just happen to think that Backstage is the best of them. So if there is something you'd like to know, you can probably get in touch with us about that. And with that, we can get to questions.
Thank you, Heiko. I guess I have one question off the bat that I feel like we need to, just in the climate right now, how does remote working affect all of this? Is it possible to have a happy, healthy team experiencing flow when everybody's remote and interacting in 2 dimensions like this?
It's not as hard as we thought it would be. So with like classical software delivery teams, it is actually not too bad. We do a lot of pair programming, and like pairing can sometimes be a pain using tools, especially if people are physically located in different, countries or even continents. Then it might get hard. But there's a lot of tools out there that facilitate like easiness of pair programming, or tools like VS Studio Code come with a very, very good inbuilt way to do pairing. The other thing is like working together doesn't necessarily always mean you have to stare at the same screen. So we found it quite useful to just assign pairs of people to a task. And sometimes they do pairing together, sometimes they do other tasks or spikes. Tools like Mural and Miro have come a long way as well. Like it basically has replaced physical sticky notes for me, which I thought that was the thing that was never going to be possible. Where it gets a little bit harder is like consulting work and strategy work. Like doing that remotely is always hard, I think. And it's always going to be of slightly less quality of like in-person work. But that said, we've done a lot of advisory work recently as well, and it's worked quite well. So all of that works. What is an interesting development is that some organizations have started organizing not along physical offices, but along, say, time zones, for example. And that is interesting because it allows us to expand the hiring pool in different regions. So if anything, the way I've experienced the like working from home situation, it's better. Like it gives me the ability to like access an entire different like pool of talent across Australia or across like different regions.
Yeah. Let's get some questions from the audience. The first one that came up when you mentioned teams of 5 to 9 people, is that just the engineering team, or does it include the other roles like QA, BA, project manager, etc.?
That would include all of them, all the roles on the team. So it doesn't necessarily matter what discipline those people have. It's more about like the amount of people that you can form a really high trust relationship with. So yeah, 5 to 9 with all disciplines. Yeah.
Supradeep had a question about how to identify domains. If you're organizing teams around domains, and then the question is, how do you identify domains? VSM? I assume that's value stream modeling.
Value stream mapping. Yeah.
Mapping.
Yeah, that's a good idea. Value stream mapping is a good idea. Another really useful technique we've used quite successfully is a technique called event storming. So it's a similar exercise, again, a bit more powerful in person, but it's like a workshop where you start identifying aggregates or domains based on a single interaction, like a value stream that we've talked about before. It's a similar kind of concept like value stream mapping, but a little bit different because you try to identify every single thing that needs to have happened in the past tense to get to an outcome. There's a couple of really good resources out there on how to do and how to run these workshops successfully, but we found them super useful to identify domain boundaries, at least course domain boundaries.
Yep. Another question. I'm just trying to decide which one to go to. Have you encountered any of the engineering team productivity tools like Git Prime or Blue Optima? Are you familiar with those?
No, I am not. I'm curious to understand how they what they think productivity is.
Yes, I agree. Blue Optima looks a bit like it's trying to identify individual developer performance, but I think it's just it's a slippery slope, isn't it? Measuring productivity and then narrowing that down to an individual.
Individual metrics are hard in general, and there's also one other thing that is probably worthwhile saying is that it's like productivity cannot be reduced down to a single metric. Like this illusion of there being one metric that measures, I don't think that applies for software engineering or engineering performance in general. It almost always is a combination of a small number of metrics, again, like individual, team, system level, but it's never like a single thing. And it's most certainly not a single activity metric or like how many lines of code a developer has checked in, because that would imply that the hardest part of delivering software is the typing.
Yeah. On the other hand, it's hard to measure outcomes in terms of when the outcome is a business outcome. It's not always easy to measure those things. Here's a good one that we always like to take on. How would you characterize the problem organizations are trying to solve using pull requests, and how would you instead solve it?
Yeah, so the reason that organizations install pull requests as a stage gate sometimes is like completely reasonable. Like they want to probably instill a collective sense of ownership in code, for example. They want to help with onboarding new team members. They want to, in some cases, make sure that they comply with government regulations like SOX or ISO or FedRAMP if you're in the US. So they use it as a way to enforce peer review. So these are all things, these are outcomes that are completely legitimate, but in most cases, it's not necessary to like go heavy-handed with a pull request. Like in most cases, we've seen organizations that are fully SOX and ISO compliant that are doing it via pair programming, for example. So but the advice would be to look at the outcome and look at what you're trying to achieve with them, and then really think about, do you need to imply or impose that heavy productivity tax that comes with a pull request? In some cases, the project I'm on at the moment with my client, we actually are very happy that we've installed a pull request model. It's because we are handling some very critical infrastructure. It's a security project. We want to get more eyes on changes than less, but we've made a couple of rules. Like we need to make sure that pull requests are merged within a single day. That just meets about the definition of continuous integration. Don't go over a single day. And that tends to help a fair bit. So again, pull requests are not the problem. Like a pull request is actually a quite useful tool to make sure you can prove that two people have seen a code change and the proof of a code change. So you can use all of that. Just make sure like you don't have pull requests sitting there for like days or weeks or months in some cases.
I think living without pull requests, going straight to trunk, means adopting a whole bunch of other practices that not everyone is prepared to do or competent with, I think.
Yes, absolutely. There's a couple of things that need to be true to build trust in your software delivery system, and that is continuous integration, continuous delivery, like the ability to install feature toggles and turn things on and off. There's a high engineering maturity that's implied in that. There's something though that just recently got published as an article about a model that is close to continuous integration but still makes use of pull requests. It's called the show, tell, ask model of making changes. So show meaning it's a small change, a pair of developers has done it, they're just merging it, and they raise a pull request that is not blocking, just to show people what they've done. Then there's a thing about there's tell, which is they still do it, and they broadcast what they've done to a wider audience, getting feedback after the fact, and maybe then making a change and iterating over it. And the last is ask, which is there's where they actually install a blocking pull request, asking for somebody to synchronously review their work. And it's a model that works quite well, but you just got to make sure that you don't default into everything being an ask. If that makes sense.
Okay. Let's go to a question from Nish. He's curious about team structure. When you have simultaneously building a platform and functional modules that can be composed into products for different customer segments, do you structure the teams around customer segments or modules? Good question.
So when you're building, yeah, it's a good question. So it's about building a platform, right? So one thing that we would advise to is use before reuse. So rather than building platform features by themselves because you think that's what a using team will need, we found it to be quite useful to just start with like building it as part of a delivery project and then extracting out, almost harvesting platform capabilities out of like actually delivering customer value. Like some places would call that conquer then divide or something like that. But that's a bit of an avoidance answer. But but when you are building platform features, yes, absolutely align. I would say align around value streams and customer outcomes. But your customers are internal customers, not external customers. So thinking about it in terms of if you have, say, a continuous integration infrastructure, like it's still a value stream, but your customer is internal. And in some cases, just recently at some of our clients, like we've seen that these internal platform teams that have a direct line to their internal customers are actually incredibly effective at what they do because the feedback they get is near instantaneous. Like think about, I don't know, hundreds of angry developers that suddenly can't do their work anymore because their continuous integration system has broken. That's quite a strong forcing function to be customer centric and go fix the thing.
I think we're just about at time. I'm afraid if we launch into another question, and there are a lot of really good questions, so perhaps you feel free to ping us offline, and if you want to continue this dialogue. There was lots of good questions, not enough time to answer them all. So thank you everybody for coming. We really appreciate your turning up for these things and all of the great questions. So hope everybody has a great rest of your Thursday, and we'll see you next time.